So we just found the leading term on this function to be negative 4x to the fourth. Now there are two things we look at on the leading term to determine end behavior. The first thing we look at is the sign. Okay, so is my sign here positive or negative? It's negative. So if we think about a negative quadratic function, so a negative x squared, this negative tells us what it's going to be doing on the right. So what is it doing on the right for a negative quadratic function? Well, it's going down, so it's negative, so it's going to be going down. Negative means it goes down on the right. The other thing we look at is the exponent. We look what do we look at for the exponent? We want to see if it's what or what. We want to see if it's even or odd. So 4 is even. So what does even tell us? Well, remember, odd means opposite, so even means the same. That means that my sides are doing the same direction. So I must be going down on the left as well. So another part of polynomial functions we're going to talk about are their zeros and their multiplicities. So finding zeros and their multiplicities. So let's first talk about some definitions. First definition is a zero. Okay, so a zero of a polynomial function is the x value of the x-intercept. So the way to find that is to just find your x-intercept. So if you want to find your zeros, you really just want to find your x-intercept. Okay, and some other words that may be used for the same idea are roots or solutions. So if you see roots, solutions, zeros, x-intercepts, it's all the same process. You're going to find it by setting your function equal to 0 and solving for x. So an example. That's not going to fit. Hold on. F of x equals x cubed plus 3x squared minus x minus 3. So we find the zeros. Zeros is just another word for really x-intercepts. We find our x-intercepts by setting our function equal to 0 and solving for x. How am I going to solve this for x? If I were there, I would hopefully hear you throwing around the F word. And no, not that F word, but the math F word that we use a lot. Factor. Okay, so we're going to factor this to find our x's. And notice how many terms do I have here? I have 4 terms, so 4 terms means factor by grouping. Factor by grouping. So group your first 2. Group your second 2. Find the GCF of the first 2. That would be x squared. Factor it out, leaves me with an x plus 3. GCF of my second one is just a 1, but since I have this minus right here, I need to factor out a minus 1. Leaves me with an x plus 3. Factor that again. X plus 3 times x squared minus 1. So now we take each of our factors and we set each of our factors equal to 0. So we get x plus 3. Oh wait, before we do that, notice x squared minus 1. This, you could either continue factoring this or you could use your square root properties in a minute when you set it equal to 0. Either one works. I just want to remind you of the factoring. What kind of factoring is x squared minus 1? It's called a difference of 2 squares. So our difference of 2 squares. So that factors to x minus 1 times x plus 1. And then we can set all of our factors equal to 0 and solve. And we would get x equals negative 3, x equals 1, and x equals negative 1. So your zeros of the function are x equals, sorry, the zeros of the function are just -3, 1, and -1. Those are your zeros. So the other thing we need to talk about with zeros is their multiplicity. So multiplicity is how many times you get that zero, okay? So if you get a zero a certain number of times, say you get a zero 3 times, then you say it's got a multiplicity of 3. But multiplicity is just how many times you end up getting that same zero. So an example. Find the zeros and the multiplicities. F of x equals x plus 1, x plus 1 times x minus 2 squared. So looking at this, notice I have x minus 2 squared. So that's the same thing as f of x equals x plus 1 times x minus 2 times x minus 2. So if I want to find the zeros of this, remember we set our function equal to 0. And then we set each of these factors, it's already factored for us, that's not, we set each of these factors equal to 0. Okay, so when I'm doing that, I have x plus 1 equal to 0. And then I have x minus 2 equal to 0. And do I really need to set this one equal to 0 again? No, it's just going to be the same thing as it is here, okay? I just get it more than once. So I just need to solve it once. So solving, we get x equals -1 and x equals 2. But how many times did I get x equals 2? Well, I would have gotten it twice because I had the factor twice. And we see that from right up here with that exponent of 2. That tells us I'm going to have that factor 2 times. So here, this multiplicity for this 0 is 2. What about x equals -1? How many times did I get that 0? I got this 0 once, so its multiplicity is 1. So now we're going to get into why finding multiplicities is important. Multiplicities tell us something really interesting about a graph. Remember, multiplicity is talking about how many times we get a certain zero. A zero is an x-intercept. So we're talking about how many times we get that x-intercept. And that changes what the graph is doing at that x-intercept. So this description is down here. So if r is a 0, so you have a 0, and if that 0 has an even multiplicity, then the graph touches the x-axis at that 0 and turns around. So it touches and turns. If it's even, the graph will touch and turn at that 0. If your multiplicity is odd, then your graph is going to cross your x-axis at that 0. Okay, so if it's odd, it's going to cross. So let me show you an example of this. So find the zeros. State their multiplicity. Multiplicity, y. And whether the graph touches or crosses the x-axis. So here's my function, f of x equals x minus 2 squared times x plus 1. So this is actually the same example we just did a minute ago. Okay, back up here. It's the same function. I wrote it in a different order, sorry. X minus 2 squared, and x plus 1. So from right here, we found that our zeros were x equals -1 and x equals 2. Sorry, I can't get this all on the same camera angle. And then the multiplicity is 1 and the multiplicity is 2. Okay, so that's all stuff we got from the last example. I'm going to draw you a graph of this actual function. So the actual graph looks something like this. So this x equals -1 and x equals 2 we found on the last example. Okay, those were our zeros. Okay, and I have a 0 here at x equals -1, and I have a 0 at x equals 2. But notice they don't do the same thing at the x-axis. Okay, recall from your green sheet, okay, even multiplicity meant what? Even multiplicity meant my graph touched the x-axis and then turned back the same way it came. So right here, this 0 at x equals 2 had a multiplicity of 2. Okay, this multiplicity is even, so the graph touches the x-axis. And that's what we see right here. The graph touches the x-axis and then turns and comes back the same way. Okay, it turns right there. It touches and turns. Okay? Whereas over here, x equals -1 has a multiplicity of 1. This multiplicity is odd. Okay, and what did we say about odd multiplicities? We said for odd multiplicities, the graph crosses the x-axis. So you can see here at x equals -1, it had an odd multiplicity. So my graph actually goes straight through that x-intercept. Let's do another example of finding the multiplicities and stating whether they touch or turn. So another example of the same type of problem. This time we're going to be using the function -4 times x plus 1/2 squared times x minus 5 cubed. So first thing we need to do is find the zeros. So we find the zeros the same way we find the x-intercepts, by setting our function equal to 0. Then my function's already factored, so I have to set each factor with an x equal to 0. Okay? Notice technically -4 is a factor, but because it doesn't have an x in it, there's going to be nothing to solve for in a minute. So just the stuff with x's. Solve these. We get x equals -1/2 and x equals 5. Now let's talk about their multiplicities. -1/2. How many times would I get -1/2? Well, how many times did I have the factor x plus 1/2? I had it twice. Okay, so I had that factor twice. So that means its multiplicity is 2. Okay, so multiplicity is 2. Is 2 even or odd? 2 is even, so my multiplicity of 2, which is even. So what does my graph do at an even multiplicity? For an even multiplicity, it is going to, so the graph touches the x-axis. So this is where it's going to do that touch and turn. It's even, so it's going to touch the graph and then turn back the other way. X equals 5. How many times would I get that? How many times would I get that 0? Well, it came from x minus 5, so how many times did I have the factor x minus 5? Well, from the exponent, I had it 3 times. So my multiplicity is 3. 3 is what, even or odd? It's odd. So the graph will do what? Odd means the graph crosses the x-axis. Okay, so now let's talk about the number of turning points of a graph. So this is on your green sheet. So if your function is a polynomial of degree n, then the graph of f has at most n minus 1 turning points, okay? So whatever your degree is, your graph can have no more than 1 less turning point. So here's my example on here. F of x equals x to the 5th minus 6x cubed plus 8x plus 1. Remember, your degree is the biggest exponent on your variable, okay? So the biggest exponent I have on one of my variables is my x to the 5th piece. So my exponent is 5, so that means my degree is 5, okay? The degree is 5. That means that the most number of turning points I can have is 1 less than 5. So my max number of turning points here is 4. Okay, so let's count this. I have 1 turning point here, 2, 3, 4. So this works, okay? And this is a check that you can do whenever we do our graphs in a minute to make sure it comes out right, because you don't want to have more turning points than what's allowed, okay? If you come out with a graph for this function that has 6 turning points, that's not going to be right because you know that your max should only be 4. Okay, but on the same hand, that's a max number. You could come out with a graph for this that only had 2 turning points, and that's an okay thing because it's less than your max number, okay? So you want to make sure the number of turning points you have is less than your maximum number of turning points. Okay, so now we're going to take all this information we just talked about, end behavior, zeros, multiplicities, and we're going to put all this together to be able to graph a function.